Okay, and the last part of 1.2 talks about concavity and inflection points. So an inflection point is where a curve changes from concave up to concave down, or vice versa. We need calculus to algebraically find where a curve goes from concave up to concave down. So we're not going to actually find it. We're going to look for it. We're going to estimate it, but we're not going to find where it actually happens at. All right, so remember, concave up means your graph is opening up. It's where your slope is increasing. And concave down is where your graph is opening downwards and your slope is decreasing. Concave up will include a local minimum. Concave down will include a local maximum. All right, so look at example 10. It says, use the graph of g of x shown at the right to determine intervals of concavity and state the points of inflection. So here we're looking at where is our graph concave up, where is it concave down, and where are those points of inflection? Now the definition of points of inflection we said is where concavity changes. But guys, a way to identify it is going to be where it's going to be a point that is somewhere in between a local maximum and a local minimum, or a local minimum and a local maximum. So I'm going to do my points of inflection first. So I notice right here I have a local minimum, and right here I have a local maximum, which means I have a point somewhere in the middle here that is that point of inflection. That's where my concavity is changing from being concave up to concave down. Okay? So I'm going to go ahead and write that. One of my points of inflection is negative 0.5, comma, negative 3. I can see I also have, let me erase what I wrote up here. Okay? I also have this maximum here, local maximum, and I have a local minimum there, which tells me that somewhere in between there, because this up here is concave down, at the 4, 0 it's concave up, somewhere in between those 2 points is my point of inflection where concavity is changing, so it must be here at the 3, 1. Now, we already talked about the concavity a little bit there. We said if it's concave up, that means it's going to have a local minimum, okay? So I can see right here that this is concave up. My graph is opening upwards. So therefore, where did it start to open upwards? So remember, you read a graph from left to right, and so as we go to the left, that number would be negative infinity. So it's concave up from negative infinity until that point of inflection where we said it's going to change concavity, which is at negative 0.5. And then what happened at that negative 0.5? Well, this is where we said it was going to become concave down. So at that negative 0.5, it's starting to become concave down. And so we know it's going to be concave down until there's some point in between, because over here we got another one that's concave up, okay? Some point in between, which was at 3, 1. So it's going to be concave down until x is 3. And then notice it's going to become concave up again. It starts to be concave up at that point of inflection at 3. And it never stops being concave up. So therefore, it goes to positive infinity. And then on example 11, it says the function f of x equals 2x cubed plus 3x squared minus 12x minus 4 is shown at the right. The relative extrema are labeled on the graph. Find the average between the high point and the low point to determine an approximate value for the x-coordinate for the point of inflection. Then substitute your findings into the function to locate an approximate point of inflection on the graph of f. All right, so to find our point of inflection, first thing we're going to do is we're going to go find the x value of it. So to find the x value of the point of inflection, I'll abbreviate it POI, we're going to take the average of the x values of that maximum and that minimum that are right there around it. So we can see here we have a local maximum, we've got a local minimum, so we know that somewhere in between here there's a point of inflection. And so to find the x value of it, we take the average of those two x's. So the x of my local maximum is negative 2, plus the x of my minimum is 1, and we find the average. So remember, we divide it by however many there are. And so I come out with my x value is going to be negative 1/2. So that means that this point of inflection right there has an x value of negative 1/2, comma, we don't know what yet. Well, remember, anytime you know an x value and they gave us an equation, we can always plug it in to solve the y. So we're not going to average the y's. It doesn't work out that way. But you know the x value, so now you plug it in the equation to find the y value. So the y value of the point of inflection is equal to f of that negative 1/2, f of that x value we just found. And so we're going to plug this in, 2 times negative 1/2 cubed plus 3 times negative 1/2 squared minus 12 times negative 1/2 minus 4. And so we plug this into our calculator and we find that it is equal to 2.5, or you could say 5/2. So this is, remember, f of anything is the y value, okay? So this says that my y value is 2.5. So we know the x is negative 1/2. We know the y is 2.5. And so our point of inflection is going to be negative 1/2 and 2.5. And so I'm just going to write that up here. So point of inflection. And there it is. All right, so that's the end of 1.2. So hopefully you're able to finish the assignment. Good luck, guys.